Okay, this is going to be the video for the A problems of the review, just in case you didn't get to finish in class today. So for 1A, we need the domain and range. So my domain is going to be from the left to the right. So I look at my far left value. It's going to be this right here. If I draw a line down, I can see it hits my x-axis at -3. Then I go to the far right value. This is going to be the far right. Draw a line down. And my x value there is 1, 2, 3, 4. So I know my first on the left is -3. Mine on the right is 4. And since it's domain, there's going to be an x in the middle. And since -3 is less than 4, we're going to put less than signs. Now at -3, we have an open circle, so we don't need to put the equal to line. Same with that 4. It's an open circle, so there's no equal to sign. Now the range, it's going to be from bottom to top. So the bottom is going to be right here. And we just need to figure out what that y value is. And the y value at the bottom is 0. Then we go all the way to the top. This is our top point. And the y value there is 1, 2, 3, 4, 5. Since it's range, there's going to be a y in the middle. And 0 is less than 5, so we have less than signs. Notice at the 0, there's no open circle. If there's no open circle, we're going to put the equal to line. At 5, we do have open circles, so we're not going to include the equal to sign. So this is our domain and range. On 2, we have to find the x and the y intercepts. So my x-intercept, I'm going to take my equation and I replace the y with a 0. So to find your x-intercept, replace the y with a 0. So the -3 times 0 is 0, so we can cross that out. And we're left with 5x equals 15. Divide by 5 on both sides. So our x-intercept will be at 3, which means our point is 3, 0. Now the y-intercept is going to be 5x minus 3y equals 15. But this time we're going to replace the x with the 0. So 5 times 0 minus 3y equals 15. 5 times 0 is 0, so we can cross that out, and we get -3y is 15. Divide by a -3 on each side, so y equals -5, which means 0, -5 is our y-intercept. Three is talking about a concert venue that holds 50 people, and each ticket costs $15. Function can be written that describes the total income of the venue as a function of the number of tickets sold. So the domain, that's going to be our that is our independent variable. And the range is going to be our dependent variable. So since the cost depends on the number of people, the range is going to be the cost, domain is going to be the number of people. So at this concert venue, we can have 0 people. We can't have half a person, so the next number we can have is 1, then 2, and I'm not going to write out all of these numbers because that would take forever, but the most it can hold is 50 people. So I'll put a 50. Then for the range, this is going to be how much the venue makes. So if 0 people attend, they'll make $0. If 1 person attends, they make $15. 2 people attend, they make $30. Then again, we're going to skip everything in between. If 50 people attend, they would make $750. So the domain is the number of people. The range is the cost. Okay, 4a. This is going to be a slope problem, so we'll label x1, y1, x2, y2. And then we use our slope formula. So y2 minus y1 over x2 minus x1, which would be negative 2 minus negative 3.5 over x2 is 5.2 minus negative 2. And whenever we have minus and negative, that turns into a positive, so plus and plus. So negative 2 plus 3.5 is going to be positive 1.5. 5.2 plus 2 is going to be 7.2. When we divide these, we end up getting 0.2083 repeating, so 3, 3. But all that you need here is 3 decimal points. So if it goes on forever, we're going to round it to 3 decimal points, so 0.208. Okay, 5a. This one wants the x-intercept, the y-intercept, and the slope. So to start off, we're going to do the x-intercept. And if we look, we first need to define what our x and y mean. So our x is going to be the time in hours, so I'm going to write hours. And the y is going to be the height in feet from the ground. So let's just say feet from ground. Now the x-intercept, where it hits the x-axis, it's going to be this point right here. It's not really a nice point, but we can call it, let's say 2.3. So 2.30 is the x-intercept. And the meaning of this, remember our x's are hours, and the y is the feet from the ground. So we can say after 2.3 hours, the balloon reaches the ground. Now the y-intercept is going to be where it hits the y-axis, so it would be 0, 3,500. And the meaning of this one is after 0 hours, we are 3,500 feet from the ground. And the last thing that we want is the slope. I'm just going to write this up here. So the slope, we need 2 points. You could use your y-intercept and your x-intercept, except our x-intercept here is at 2.3, so that's kind of ugly. So what I'm going to use is a different point. You can pick any 2 points and you get the same slope. So it's going to be -1 and let's say 2,000. So my 2 points I'm going to use are 1, 2,000, and 0, 3,500. Then I can label these x1, y1, x2, y2. Then I just use my slope formula. So y2 minus y1 over x2 minus x1. Plug them in, I get 3,500 minus 2,000 over 0 minus 1, which simplifies to 1,500 divided by -1. So negative 1,500 feet per hour is going to be our slope. And that is just going to be the speed of the hot air balloon. Okay, 6a, we need to circle which one is a function. And to be a function, the x values cannot repeat themselves. So if we look at a, we have -5, -2, 1, 4, 10. All of those x values are different. That means a is a function. On b, notice it's a mapping, and it says 5 goes to 2 and 5 goes to 4. Whenever it's like this, that's basically like having two 5s. So since the x's repeat themselves, b is not a function. Okay, 7a, we're going to find the rate of change of this table. And the rate of change of a table is the change in the y value over the change in the x value. Now you can pick any two rows to find the change between. So I'm going to pick the two that are whole numbers. So I'm going to pick -28 to -8, -4 to 1. So as long as they're in the same row, you can pick them. I'm basically just going to act like this row doesn't exist. So my change from -28 to -8 is plus 20. My change from -4 to +1 is plus 5. So my change in y is 20. My change in x is 5. When you simplify that, we get 4. So my slope here would be 4. (8a) is function notation. So I have the function f of x equals -3x plus 8. And we're trying to find f of 4. So I replace the x with the 4. So f of 4 equals -3 times 4 is -12 plus 8. So f of 4 equals -4. And that's our answer. Nine wants to know which one of these represents a direct variation. And we talked about to be direct variation, it has to pass through the origin, which would be this point right here. So since this line does not pass through the origin, it is not direct variation. And another way to say the origin is the point 0, 0. So if we look at this table here, notice it passes through 0, 0. So B would be direct variation. It just has to go through the origin or the point 0, 0. Here we have to write the direct variation equation. And if you remember, that was y equals kx. And remember, k is just going to equal y over x. And it tells us y equals 5, x equals 7, which means our direct variation equation is 5 over 7x. So you have to include the y and the x in that. And the last one is 11a. So we have a word problem, and it's asking us to find the constant rate at which the water is rising. That just means the slope. And we can make some coordinate points out of this. We know at hour 1, the water level is at 12 feet, so 1, 12. At hour 5, it's at 36 feet, so that could be our second point. 5, 36. And then we have an x1, y1, x2, y2. Which means our equation would be y2 minus y1 over x2 minus x1. So we'd have 36 minus 12 over 5 minus 1, which simplifies to 24 over 4, which means our slope is 6 here. And it would be 6 feet per hour. And that is all the A problems from the review.